what I want to do in the rest of this talk is tell you where that vision takes us. I want to tell you about what it means that we're not made of particles, we're made of fields. And I want to tell you what we can do with that and how we can best understand the universe around us. Okay? So here's the first thing. Take a box and take every single thing that exists out of that box. Take all the particles out the box, all the atoms out the box. What you're left with is a pure vacuum, and this is what the vacuum looks like. So what you're looking at here is a computer simulation using our best theory of physics. It's something called the Standard Model, which I'll introduce later. But it's a computer simulation of absolutely nothing. Okay? This is empty space, literally empty space with nothing in it. This is the simplest thing you could possibly imagine in the universe. And you can see it's an interesting place to be, empty space. It's not dull and boring. What you're looking at here is that even when the particles are taken out, the field still exists. The field is there, but what's more, the field is governed by the rules of quantum mechanics. And there's a principle in quantum mechanics, which is called the Heisenberg uncertainty principle, which says you're not allowed to sit still. And the field has to obey this. So even when there's nothing else there, the field is constantly bubbling and fluctuating in what's, quite honestly, a very complicated way. Okay? These are things that we call quantum vacuum fluctuations. But this is what nothingness looks like from the perspective of our current theories of physics. Okay, it's worth saying that this is a computer simulation. It looks a little bit like a cartoon, but it's actually quite a powerful computer simulation that it took a long time to do. But these aren't just theoretical. These quantum fluctuations that are there in the pure vacuum are things that we can measure. There's something called the Casimir force. The Casimir force is a force between two metal plates that get pushed together basically because there's more of this stuff on the outside than on the inside. And these are real. These are things that we can measure, and they behave just as we would predict they would from our theories. So this is nothing.